Hello everyone, welcome to the lecture again. Today we are going to start a new topic called structure, and particularly we are going to look at plane trusses. So let me first define what is a truss. So you can see the picture over here. So for example, this is a truss and this is the example of a planar truss because the members are in a plane. Okay. So by definition, a truss is nothing but a framework which is composed of members which are joined at their ends to form a rigid structure. So, for example, you can see here these are the members and they are joined at their end. So, these are members and these are the end and they are joined together to form a rigid structure. What do I mean by rigid? Rigid means that when we have this structure should not fall down. This truss is one of the major type of engineering structure and it provides a practical and economical solution in design of bridges and buildings. Why it is economical? Because you can see here the entire structure is not filled with the material. Okay. So, therefore, this need less material and therefore, it is more economical. Now, as you can see here in the truss there are many component. So, the first one is the member. So, these members are nothing but these beams that you see here. So, for example, this one, this one, this one, this one and this one, they are the member. So, basically they are bars or they can be I-beams. Now, we can also see in the truss that these members or the bars, they are joined at their end. So, there are joints. These joints can be welding or by weld, they can be bolt or by bolting, they can be rivet connection or more commonly it can be pin joint. Now, when I say pin joint, so if we have pin joint then we already know that the pin joint cannot support the moment. Okay. So, basically about this pin joint there is a freedom that the beams or the bars can rotate slightly. Okay. Now, if your truss is big then we also need to support it. Okay. So, you will see in many problem that you have support which will hold this truss. Okay. So, these are for large truss and the supports can be roller support or rocker support, etc. Now, this is general definition of the truss. Now, the second figure that you see here, this is a plane truss. So, this is a general example of the truss. Now, let us see what is a plane truss. When the member of the truss, so when I say member, I mean bars and I-beams, they lie in a single plane, then the truss is called a plane truss. Okay. And as I already said, what is a rigid truss? A truss is said to be rigid if the truss will not collapse. Okay. Now, let us look at some example. Let us say I have a bar and I connect another bar using a pin. Now, this pin, so from the pin the bar can rotate. So, therefore, you can visualize that this truss is not rigid because from this end the bar are going to rotate. So, this cannot be sturdy. So, therefore, if the question is it a rigid truss, then the answer is no. Now, let us look at another structure. So, let us say I have this bar, now I connect another bar and then I put one more bar. Now, even if these bars are, they are free to rotate about these point, still this structure will not fall down. Okay. So, therefore, if I ask that is this a rigid structure, then the answer is yes. Now, let us look at this structure. So, suppose this time I have 4 bars. Now, if you give this structure the freedom to rotate about these points, then you can see by yourself that this structure will not be sturdy and it will fall down. Okay. So, therefore, again this structure is not a rigid structure. Okay. So, you can see that this triangle structure is basically the building block to make a rigid structure. So, the basic element of a plane truss is the triangle. So, let us say in this example wherein we have 4 members. So, let us say I have 4 members. So, as I said that this structure or this truss is not a rigid, but since the basic element of a truss is triangle. So, therefore, if you connect one more member like this, then this structure will become a rigid structure. So, now this is a rigid structure. Okay. So, how do I make larger truss? So, to make a larger truss, what you have to do is you have to add 2 new members to existing joint and connect a new joint. So, basically you start with a triangle structure. So, let me start with a triangle structure because this is our basic building block. Now, I have to make a larger structure. So, what I have to do is I have to add 2 new members. So, let me add 2 new members. So, let us say one member is like this and another member is like that. So, I have add 2 new member at 2 existing joint. So, this is one joint, this is the second joint. So, I have add 2 members and then you connect it with a new joint. So, let us put a new joint here. So, therefore, now the structure or the truss has become big. Now, again if I have to extend it, let us again connect 2 new member. So, let me connect this member and then let me connect one more member and then again I put a new joint here. Okay. And if I have to extend it further, so again I can do the same thing. Well, I can put one member, then I can put the second member and add another joint. Now, let us see how do we analyze this truss. So, analysis of the truss. So, by the way, what is the meaning of analysis? Meaning of analysis is to find out how much tension is acting between different members, what is the tension at the pin, etc. So, to analyze the truss, let us first make some assumption or some idealization, and the first assumption will be the weight of the members are negligible. Okay. So, we will not consider the weight of these members because they will support much larger weight than their own weight. And we will also consider that all the joints are pin joints. Okay. So, as I said previously that the joints can be welding, it can be bolt, it can be revert connection or it can be pin joint. For the analysis, we will consider that the joints are pin joints. Now, in these trusses, you will see that there are member and sometimes these members are under tension or sometimes they are under compression. So, let us see in which case they are under tension and in which case they are under compression and what is the meaning of that. So, if the forces tend to pull the member, then the member is under tension, and if the force tend to push the member, then the member is under compression. Okay. So, for example, let us say this is one of the member and the forces that are acting on this member is, let us say, like that. In this case, this member is under tension. Similarly, let us say again I have this member and in this case the forces that are acting on the member are like that. In this case, this member is under compression. Okay. Now, similarly, you can also think of the pin that is there. So, let us say I have this pin and on this pin let us say various forces are acting. So, let us say this is force 1, this is force 2 and then I have force 3. Then you can see that force F1 and F2 they are pushing the pin. So, therefore, it will be a compressive force and force 3 is the tensile force, tensile or tension force, whatever you want to call it. Now, let us look at the classification of the truss. So, truss classification. So, as I discussed earlier, in the truss there are many members. Let us say the number of the members are m. So, here this member I write down m and let us say the number of joints Rj, and suppose this truss is kept on some surface. So, therefore, you will have the reaction force. So, let us say there are some reactions R. Now, if M plus R is equal to 2J, in this case the truss is called statistically determinate truss. So, this is called statistically determinate. What is the meaning of that? Well, statistically determinate mean you can calculate all the forces that are acting on the truss, and if your M plus R is larger than 2J, in this case the truss is statistically indeterminate. Okay. And how we get this condition? Well, R is the reaction forces, and usually we do not know these reaction force. So, if there are R reactions, then these R's are unknown. Okay. And if there are M members, so there will be M forces which will act on it. So, therefore, M is also unknown. Now, for every joint there are J joint. For every joint we have two scalar forces Fx and Fy, because it is a planar structure. So, therefore, there is no force acting in the z direction. So, we have Fx and Fy. So, there are two known, and note that moment equation we cannot use because this structure does not support the moment. So, there are 2J known and R plus M are unknown. So, therefore, if M plus R is equal to 2J, only then we have sufficient equation and we can determine all the forces that are acting on the truss. Now, let us see how do we analyze or how do we compute all the forces. So, there are two methods. The first one is called the method of joint. So, just to tell you that there are two techniques for computing the internal forces in a truss. The first one is, let us say, method of joint. So, this technique of method of joint, it is most effective when we want to calculate the forces in all member of a truss. So, we will look at these in detail, but when you have to calculate all the forces or all the internal forces that are acting on the truss, in that case we will use method of joint. And if so, the second one is method of section, and this is most effective or more effective when we need to calculate the forces in only one or in very few members. So, now with this very basic introduction, now let us look at couple of examples which are based on method of joint. So, this is of course very simple truss, and the question statement is determine the force in each member of the loaded truss. Loaded because we have external load which are acting at point B. So, to analyze this, the first thing is to make the free body diagram of the entire structure or the entire truss. Okay. So, let us make the free body diagram. So, we have, so just for simplicity I am just making this, but it is not required. So, you have a pin here and you have a roller support at this point. So, this is a pin support, this is a ruler, and then we have all these members like this, and then at B it is connected by a pin, then you have a 100 kg load. Now, let me draw various forces. So, because it is a pin joint, there will be two force, two reaction force. So, let us say because this point is A, let us say the horizontal force is Ax and the vertical force is Ay. At C, since it is a roller support, so therefore, it cannot support the reaction in the y direction. So, it will have only horizontal force. So, this point is C. So, let us call this force Cx. So, this makes the free body diagram. This is 12 meter, and as I said, to analyze this, let us first consider the entire truss. Okay. So, entire truss, and we are looking at free body diagram. So, let us apply the force equation summation Fy equal to 0. So, clearly you can see if I use summation Fy equal to 0, you get Ay equal to 100 times G. Let us call it equation number 1. And if I use, so this is summation Fy equal to 0, and if I balance the forces in the x direction, then you can see that Ax is equal to Cx. Okay. Actually, there should be a minus sign because both are in the same direction. So, therefore, the direction for either Ax or Cx should be opposite. So, let me make this Ax in this direction. So, now it is correct, Ax equal to Cx. Let us call it equation number 2. Now, to find out what is the value of Cx or Ax, let us take the moment about A. So, if I take the moment about A, then the contribution of Ax and Ay will go away. So, we have 100 kg force. So, 100 into G is the weight multiplied by the perpendicular distance, which is 12 meter, equal to Cx into the perpendicular distance is 5 meter. So, this immediately gives me that Cx is 240 G, and therefore, I also know what is Ax. So, this reaction forces and other values, they are calculated by considering the free body diagram of the entire truss. Now, let us do it joint by joint. So, let us consider joint A. So, let us make the free body diagram of joint A. So, this is point A, and here I have a force. So, this is let us say A. So, at A you will have a force which will act from A to B, and I also have a force Ay which is acting at point A, and I will have a force acting from A to C. So, this is FAC, and then there is a force Ax which is acting at point A. Now, some of the force we have already find out. So, let us put those values. So, for example, Ay I have calculated, this is 100 G, and Ax also we know because the value of Ax is equal to Cx and Cx is 240 G. So, therefore, this is 240 G. So, this makes the free body diagram of joint A, and now we can balance the forces. So, you can see that FAB is nothing but 240 G and FAC is equal to 100 G. Okay. So, we have find out how much forces are acting in AB and AC. Now, to further calculate the other forces, let us look at other joint. So, let me consider joint C. So, now let us see how many forces are acting at C. So, at C you will have a force Cx, then you will have a force which will act from C to B, and we will have a force which will act from C to A. Okay. So, let us call it FAC or FCA, whatever, and from this direction, to balance it, I know that the force should act downward. Okay. So, this force direction is not very important. As I said earlier, that if the force comes out to be negative, in that case you change the direction of the force, but here it is very obvious because I put the force FAC upward. So, therefore, to balance the vertical force I have to put FBC downward. Now, let us find out the forces. Let us say this angle is theta. Okay. So, I said this angle is theta. So, I can find out the values of tan theta, sin theta and cos theta from the geometry. So, let us balance the force. FAC will be equal to FBC cos theta, or FBC is equal to FAC over cos theta, and FAC just now I have calculated, it is 100 G divided by cos theta is 5 divided by 13, because this will be square root 12 square plus 5 square equal to 13. So, therefore, this comes out to be 260 G. So, therefore, we have calculated all the forces that are acting in different part of this truss. Now, let us look at another example, question number 2. So, here again the problem statement is determine the force in each member of the loaded truss. So, again let us make the free body diagram of this. So, we have a pin joint here, and we have a roller support here, and then this angle is given as 90 degree, because this is 60 degree, this is 30 degree. So, therefore, this has to be 90 degree, and from here you have a weight of 400 kg. Now, let us put the forces, the reaction forces. So, since this is a pin joint, so we will have a force in the AX direction and the force in the Y direction. Here it is a roller support. So, therefore, there will be only force in the X direction. So, this point was A, this point was C, this point was B. So, therefore, let me put a force in the X direction. So, this makes the free body diagram. Now, let us balance the vertical forces. So, you can see from the vertical forces we get A y equal to 400 G, and also you can see that A x is equal to minus C x. So, this we get by considering the free body diagram of the entire truss. Now, let us look at it by joint. So, let me consider the free body diagram of joint B. So, at B you can see that there is a force of 400 G which is acting downward, and then there will be a force along AB. So, let me put the direction like that, and there will be a force along BC. Okay. So, let me put this force like that because I have to balance the horizontal forces of FAB. So, therefore, I am going to put it like this and let us call it FBC. Now, from the geometry you can see that this angle is 30 degree and this angle is 60 degree. So, now let us balance the forces in the x direction. So, let me use summation Fx equal to 0. This gives you FBA sin 30 degree equal to FBC sin 60 degree, and sin 30 is half. So, therefore, FBA into half equal to FBC sin 60 is square root 3 by 2. So, I get FBA equal to FBC square root 3. Let me call it equation number 1. Now, let us balance the force in the y direction. So, summation Fy equal to 0. So, I get FBA cos 30 degree plus FBC cos 60 degree equal to 400 G, and let us put the value of cos 30 and cos 60. So, I get FBA from equation number 1 is FBC square root 3 and cos 30 is square root 3 by 2 plus FBC half equal to 400 G. So, I get FBC into 4 by 2 equal to 400 G, or FBC equal to 200 G. And if I put it in equation number 1, then I get FBA equal to 200 G square root 3, or let me just write down 200 square root 3 into G. So, I calculated the force along BC and along BA. Now, to calculate other forces like FAC, let us consider joint A. So, let us look at the free body diagram of joint A. So, at A I have a force which is acting in the y direction, AY force, and then there will be a force along AC, and there is a force along AB, and the angle between FAC and FAB is given, it is 30 degree. Now, let us use the force balance along the y direction. So, summation Fy equal to 0. So, we get Ay equal to FAC plus FAB cos 30 degree. Ay we have calculated, Ay is 400 G. So, you can look at this equation, and FAC plus FAB, FAB is 200 square root 3 G, 200 square root 3 G, and cos 30 is square root 3 by 2. So, therefore, I get FAC equal to 400 G minus 300 G, or FAC equal to 100 G. So, with this we have calculated all the forces that are acting in this member. So, with this let me stop here. Thank you.